So this was the pop quiz 70, which was related to metals and energy change. So in the first question, the reaction of the four metals are given. W, X, Y, and Z are listed, as you can see. The first one, they say the metal W displaces metal X from its oxide. So like metal X was there, and when it is reacted with metal W, the metal W displaces this X. So it means it will form W oxide and the X will be separated. So what it shows about the reactivity between W and X, so it shows that W is more reactive than X. This is from the first one. Then metal Y has a greater tendency to form a positive ion than metal W. So tendency to form a positive ion, highly reactive metal have a greater tendency to form a positive ion easily. So it means the Y is above W. And then aqueous ions of a metal Z are reduced by X. So when we have ions of Z, like Z ions were there, like example, a +1, and X is reacted. So Z will turn into an atom, like the charge has reduced, and X will form an ion. So which is more reactive? Because X has turned into an ion, so it means X is more reactive, and Z is the least reactive. So when we check the reactivity, this will be the most reactive, and Z will be the least reactive. So least reactive is Z, then followed by X, then W and Y. So D will be the right answer for this. Is it clear, this question? In question 2, silver is below copper in the reactivity, which should describe the reactions of a silver. So below in the reactivity, like means it shows it is a less reactive. So when we talk about the reaction of the metal, like we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, gold, silver, platinum. So when we talk about the reaction with water, so sodium, potassium, sodium, and calcium, they can react with cold water. And till lead, they can react with steam. And copper and below, like till iron actually, they can react with steam. And lead, copper, mercury, silver, so there is no reaction. So first one, reaction with steam, so there should be no reaction. So either A can be an answer or B can be an answer. Then reaction with dilute hydrochloric acid, reaction of acid for these, again, it is based on the reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. Till here, they can react with dilute acids. Below lead, they cannot react, they can only react with concentrated. So silver is again here, so silver does not react with dilute acid, nor it react with steam. So that's why A will be the right answer. So least reactive or a less reactive metal does not have a tendency to react with water or cold water or steam, or as well as dilute acids. Hydrochloric concentrated it can, but not with the dilute. In question 3, you have the energy profile diagram for this reaction is shown, as you can see. Name the energy change level A. So from reactant till the start of reaction, what we call that as activation energy. Name the energy change level B. So we can say this the enthalpy change or energy change or energy of a reaction. Energy change of a reaction or energy. State how the profile diagram shows it's an exothermic reaction. How we know it's exothermic reactions? Because when you check the energy of a product, the product is having less energy and the reactants are having more energy. So we can mention here reactants have high energy and the product is having low energy. That's why. So that's a simple way to identify because a product is having a low energy than the reactant compared to the reactant. If it was an endothermic reaction, then the product will have a high energy. In question 4, the equation for the reaction can be represented as shown. Calculate the energy needed to break the bond, then energy release when the bond making happen, and then the overall energy change. So if you want to calculate the energy needed to break the bond, so bond breaking, you can see like there is a carbon-carbon bond is there. Then 1, 2, 3, 4, 5, 6 hydrogen carbon bonds are there, carbon hydrogen. And then we have chlorine-chlorine bond. So carbon-carbon bond energy is given 350 plus carbon hydrogen bond energy 1, 2, 3, sorry, 6 are there, not 4. By mistake, I write 4 here. So it should be 6. So we write 6 CH bonds are there. And that is 410 plus chlorine-chlorine bond energy, that is 240. So 240. When we add, this will give us the energy needed to break all the bonds, which is about 3050. Then energy release when the bonds are forming. So bond forming 1, 2, 3, 4, 5. Like there's a carbon-carbon bond and there are 5 CH bonds are there. And one CCl bond is there, carbon-chlorine bond, and one HNCl bond. And we just substitute the values. For carbon-carbon, it is 350. For carbon-hydrogen, it is 410. Carbon-chlorine is 340. And hydrogen-chlorine is 430. So this will give us the bond forming energy, which is 3170. Then energy change. How to work out the energy change? Energy change is bond breaking minus bond forming. So bond breaking was 3050 and bond forming is 3170. When we simplify, we get minus 120. So if you get a negative 120, this gives an idea that this reaction will be exothermic reaction. Is it clear discussion? So bond breaking minus bond forming will give us the energy change. So this was the pop quiz related to the metals and the energy change.